What's the key to understanding calculus? Let's take a look at it using graphs only, but still, this is a video for serious math students, please be aware of that. Okay, so I'm going to draw a graph here, and then I'm going to draw x squared, like that. You've seen this graph before. Now, if you look at it from this distance, from far away, right? What I mean by that is look on the horizontal. It goes from negative 40 to 50, and the vertical goes from negative 40 to also like 50, maybe even 60 up there. It certainly has curvature, right? But now, here's a key to this. You zoom in over a tiny portion, and if you zoom in over this portion, now it's from like negative 3 to 3, and then down here it's still negative 2 to like positive 4 or 5. As you can see, it looks curved. Okay. But then, the beautiful part is now I'm going to zoom in over a tiny window. Okay, now perhaps you're beginning to see a pattern emerge, which is maybe it's beginning to look a little bit straighter. Okay. But now look at it. This goes from like negative 0.05 to 0.2, right? And then goes negative 0.05 to like 0.15 on the vertical. That's not enough still. Now look, I'm going to zoom in on a tiny portion of the graph right there. Look. Now it really looks like a straight line when you zoom in on a tiny portion. Look at the window horizontally. 0.045 over to 0.065. On the bottom, negative 0.005 to 0.01. And locally, what I mean is over a tiny window, tiny in terms of the change in x, right? And then the change in y, the graph looks like a straight line. And this then becomes a key to calculus, the fact that you can do this with a graph that at first looks perhaps even complicated. So let me show you another example, right? Okay, let me throw this in here. Another graph. Let's make it complicated. So I'm going to do the basic sine curve, sine that, okay, sine of x. And again, when you look at it from this dimension, so to speak, looks wavy, okay, then you zoom in a little bit. It doesn't matter where you zoom in, just zoom in somewhere. And the wave form is still present. But now look on the bottom, right? It goes from 11 to 18, and then it goes from like negative 1 to positive 1, the maximum and minimum values. That's not the point of calculus, though. The calculus tells you this instead. Look, just grab any part of the graph right here, okay, where it kind of looks super curvy anyway, right? Like this. And when you zoom in, it begins to look like a straight line. And if that's not good enough, then you take a tinier portion of it, and then it looks pretty much like a straight line. Look on the horizontal, it goes from 14.535 to 14.555. That's a very small change in x. Look on the vertical, it goes from about 0.91 to 0.925, more or less. Again, a very small window, and at that level of zooming in, all you have is a straight line. And because we can do that with graphs and functions, and we can look at things over tiny windows, all of calculus just emerges from this kind of understanding in a certain sense. It's amazing, really, if you think about it. Leave a like if this has been insightful.